Ever wonder how your phone thinks? We're about to decode the secret language of machines, combinational logic.
So how can a simple on or off switch lead to, really complex smart decisions? Well, it all starts with this, the Boolean variable. It's basically the machine world's two-letter alphabet.
So here's our game plan. We'll learn the alphabet, then the words, and then master the grammar.
All right, first up, let's meet the core words of this digital language, the logic gates.
This is the AND gate, kind of like a vault door that needs two keys. You need both.
And you can see here it's super strict. Only when A and B are 1 do we get a 1 out.
Now the OR gate is way more relaxed. Either of its inputs can flip the switch to on.
Yep, check it out. If A or B is a 1, the output is a 1. Easy, right?
Then we've got the NOT gate. I like to call it the opposite gate. It just flips whatever you give it.
Okay, so we've got our words. Now let's learn the grammar that puts them together. Boolean algebra.
This is just the rulebook for combining those gates to build something actually useful. But why bother with all these rules? Well, because in the world of circuits, simpler is always smarter. Think about it. Simpler circuits are cheaper, they run faster, they sip power, and they just plain work better. So with algebra, we can take this complicated mess and turn it into this. Way cleaner, right?
And how do engineers pull this off? They use a clever visual trick called a Carnot map, or K-map.
Okay, so let's connect all this abstract stuff to the actual gadgets in your pocket.
It's like Legos, really. Bits build gates, gates build functions, and functions build real components.
And this is how we get all those standard parts you hear about, like decoders and multiplexers.
A decoder, for example, is just a translator. It takes a binary code and turns it into one specific action.
You've seen this a million times. It's the little circuit that powers the display on a digital clock.
So, next time your calculator gets it right, is it really doing math, or is it just speaking a perfect sentence?